In the last video we saw how we can use those two operators, the dereferencing operator and the address of operator, or the ampersand. And we saw this kind of thing before. We set up a variable x, set it equal to 0, declare a pointer variable. It's a pointer to an int in this case. Have it point to this variable x, and then if you change star p, we see that the x changes. So I hope that makes sense. Hope you're able to figure out how this works, because this kind of pointer manipulation is something that we will see a lot of in C programs. Another thing that we could do is maybe declare another variable q, which is also a pointer to int in this case, and then we can copy whatever p has into q. So at this point both p and q point to the same thing, that is x. We can assign a value to the thing that p points to, which will, as we know from the previous example, we know that this will change x to have the value 1. And if we change star q to 10, what we're really doing is changing the value of x from 1 now to 10. So now if we print out x, we will get the value x is 10. Okay, so a few things about pointers. Initialization, although this is not checked by the C compiler, it's always a good idea, to be safe, to initialize pointers to the null value. Null is something that's defined in the file standardlib.h or stdlib.h to be equal to 0. So you can use 0, but it's just a nice way to indicate to someone who's reading your program that what you're really doing is you're setting a pointer to be equal to null. What does null mean? It means that you're not pointing to anything. However, you do want to be careful. If you have a program where you set a pointer to have the value null, make sure you do not dereference it, because if you do, your program will throw a segmentation violation exception. So let's see how that looks. lec17.c, what you want is you want standardlib.h. So let's put that in. Then I'm going to get rid of some of this and say int star. All I want to do is show you what happens if you were to dereference a null pointer. So let's do that. Okay, so we're going to do the same kinds of things as before. This is a very simple program, but all we're going to do is I'm going to say j points to j doesn't point to anything. It's a null pointer, and so we'll print out j points to, and we'll do a star j. See what happens. All right. There's our program. Let's compile it. And it compiles fine. Let's run it. And we get this error message that you will probably see quite a few times in the coming weeks. This is called a segmentation fault or a segmentation violation error message. So what happened was our program crashed. And your program will crash as soon as you try to dereference a null pointer. It's not because you're printing, for example. So let's take a look in the debugger. Compile this in debug mode and start up GDB. Do a list. It's a very small program. And we'll break at the very first line in the main. That's at 4. Run this program. And so here we are at line 4. We'll do a next and go on to the next line. And it's now in this printf, in this call to printf that the error happens. So if you do a next here, we get this bad access. So what we're trying to do is trying to find out whatever is stored at j, and j has the value null. And if you try to do that, you get something saying you're trying to access an area of memory that is not available to us. Okay. So let's maybe try a simpler, even simpler program. See if that changes anything. So we won't even print. And we'll just say int I is equal to whatever j is pointing to. So all we're trying to do is find out what j is pointing to and save that value into a variable called I. Should be able to do that, but you'll see if you run this program is get the same thing, segmentation fault. So this is a very simple program. Just 3 lines of code, and you get a segmentation fault. That is, a program crashes at this point. And you can go through the debugger, small program like this. You can see that this is where you run into problems. It's not because we're trying to print it. It's just the fact that we try to dereference a null pointer. This is something that we'll see a lot of, so keep this in mind. Dereferencing a null pointer is not a good thing to do. The other thing is to note is that if you want to use null, you have to have that pound include to include std standard lib.h as well. Otherwise, you might just get a warning. It'll probably still work. Let's finish up this video with a look at some differences between C and Java. So Java has packages. C does not have anything like packages or classes. It does not have a garbage collector, and this is going to be extremely extremely important when we get to dynamic memory allocation. Java does have a garbage collector which takes care of what a garbage collector does is take care of deleting data or memory that you no longer use. So if you use some memory from the heap, the garbage collector goes around and looks if there are things that are allocated on the heap that are no longer in use. And how does it know that? Well, if there's nothing pointing to some area of heap memory, the garbage collector knows that, well, nothing is referring to it, and therefore it can be reclaimed for use for something else. So this is what keeps track of use of dynamic memory. Another difference between C and Java is it does not have a quote-unquote built-in GUI like the swing classes in Java. In C, you have to use third-party libraries, so there is no default graphical user interface system. If you do want to write graphical user interface programs, you have to use library functions, and there's many of those. C does not have exceptions either. C does have pointers, and Java has something similar. It has references, but References are very safe to use. Pointers can be extremely unsafe, and you can have all kinds of bad behavior in programs crashing, giving you the wrong results, and so on. It's very easy to run into problems, but at the same time, C makes it the way pointers are used makes C a very flexible programming language. Okay, and we haven't quite looked at this yet. C has arrays of characters for strings, whereas Java has a string object. So since it's an object-oriented language, it has a string class, and that makes it very easy to use strings, whereas in C, once you get used to it, it's not that bad, but it does take some getting used to, using arrays of characters to represent strings. Okay, so let's take a look at the use of strings in C programming. C, like we just saw in the previous slide, does not have a built-in string type, and so what is used in C is an array of characters. So how do you declare that? You just say char str, and then in open close square brackets you say how long the string is. All you're really saying is that you have an array of characters. And so this is most of what makes a string in C. There's one more important piece of information. That is that a string in C is always terminated by a null character. And this is a convention. This is not actually part of the language. So in terms of language, this is all you need. This is the only syntax you need. So as with any other array, you say what type it is, you say what the name is. This is just a name. You can be anything you want in your program. And then you have the open close square brackets and the number of elements in that array. So what's not part of the syntax but is part of the semantics of strings is that strings in C are always null terminated, or should be null terminated. That is, the end of the string is indicated by a null character. A \0 is how we denote that. So for example, if we set up an array of 10 characters and we assign it, we can do things like assign this to anything in double quotes. It can be an empty string, or it can have double quotes with some number of characters between those double quotes. It turns out what happens is you get all of these characters between the double quotes plus one more character, and that's the null termination character. Okay, so it's just a quick preview of strings, and in the next video we will take a more detailed look at how to use strings in C.